Welcome back to the channel. We're still chipping away at the Triumph. So we ended the video last week. You might remember that we couldn't get the horn working. That was actually our fault. We wired the switch straight up to the horn, which is wrong, which means it has no power. So we just need to fix that quickly today. We're going to add in a relay as well for the horn, give it power, because then it will work. And we also have a new relay for the indicators. So this is it here. So I'm going to be swapping this out now. This is the old indicator relay. We're going to be putting in this new one in place of it. So yeah, that's what's on the cards for today. Hopefully we'll tidy up all of this rat's nest, get the headlamp put back together, and we'll have a better silhouette of a bike, and we can kind of demonstrate how everything's working, fingers crossed. Yeah, so for people interested as well, this bike is going to be for sale once we have everything sorted. So if you like Old British Bikes or you like what we're doing, and you're interested in buying this bike, hit us up. I'm going to post when we'll have it listed online. So yeah, just keep that in mind if you like what you see. Whenever we have this up and running, we're going to have it up for sale so we can then fund the next project bike.
We have an issue with the horn not working. We have the horn wires in here somewhere. So we're going to trace those today and find out what the problem is. I'm also considering that we should possibly use a relay on the horn, because I think it takes quite an amount of power. And the switches up there, the contacts on them, they're not great. So it may make the switch more reliable. These two wires here, from the light for the clocks. There's an internal light on each clock, and I belled those out. These are the two wires, the two bulbs. They go in to the bottom of the clock, and these are just little waterproof grommets. So these two are working okay. We can connect those up, so when the headlight is turned on, these come on and the clocks have a bit of illumination in them. So I think we should do that today, do the horn today, and then we can progress down to do the back of the bike. So yeah, let's get rocking with that. We're just going to test the horn works. So we have our little power supply unit here. Give us some juice to that, some juicy Lucy. And positive, negative. That's definitely working. Okay, we're good to go with the horn. We're just going to test the accuracy of this, because we're thinking we'll wire this in onto the ignition switch, so we have some idea that the bike is actually turned on. At the moment I have it set to 13 volts. And what's it reading there, Adam?
12.7.
So yeah, it's varying between about half a volt out. Adam's doing this light for the clocks, one of the clocks.
So I fitted this one already. So we're going to earth it here to the nut.
Very good, yeah.
And then this wire is coming down through this. There's a small hole here in the back of the lamp.
So we're going through there. We're going to need to get a grommet for that eventually, just so it doesn't machete its way through the wire, because it's just, whoever did that just did it with a drill and didn't even round it off.
Did it with his scissors.
Maybe yeah, drilled it with a nail.
The ends tend to just fray outwards, and then they become a nightmare to work with. So if you just trim them down, and then you can also melt them a bit with the soldering iron, which keeps them in place.
Oh, so you cut it down to size and then kind of heat it with the soldering iron?
Yeah.
Just to stop it fraying again?
Yeah, exactly. Yeah, it kind of holds it in place a bit.
Oh yeah, okay.
Just going to have to
twist it on, yeah.
Mash it down a bit, and then once you get it all the way over the sheath, then you can kind of just push it back
figure
up
out your
over
length,
yeah.
then, yeah, and then heat shrink it. It just shows you how meticulous it is. Like, you think, oh, we'll just throw a little bit of, expandable braiding onto the cable just to protect it, and it's just really simple. But each one is literally custom made to suit.
Then I'll just trim those back a bit, and then yeah.
Is there a shake-proof washer on that?
Not on this one, no.
There's a box of washers over there. You'll find a shake-proof washer in it. All from Lidl's Middle Aisle, who are not sponsoring this video. And we little shake-proof washers down here. Just because this is you know, it's an old bike, and they're renowned for kind of bone shaking.
Yeah, that one works.
So what we'll do is we'll connect the positive wires from both of those lights to the low beam switch circuit of the relay here. So we'll redo this. We'll snip this off and add those wires in and heat shrink it and make it nice and tasty looking. We've got all of the clock bulbs in and wired up quite nicely, and the earth's connected. Almost invisible earthing. Adam's in the middle of getting some wiring together for the horn relay, and we're kind of splicing into the horn wiring to include the relay. We left it out last time and the horn didn't work, and we decided to do it a different way this time. So this is power coming in. This will be going to the switching side, or not the switching side, the power side of the relay. And this will be the other side of it. That's the feed to the horn. This is a feed, just a power feed. And then we jump across to the switching side of the relay, the low power side of the relay. And then that'll go onto this other wire as well. So progress has been made. Okay, Adam is preparing another connection here for supplying power to the voltmeter. It'll prove that the ignition is on, if nothing else.
So sorry, one.
Yeah, you go far ahead there, yeah.
I'm after running the earth.
Oh yeah.
Here.
Right, okay. So back to this little nut here. We've got the earth on this. And then you run a wire through the hole in the casing here. Yeah,
I extended the wire and then put some
braiding on
and
it.
Heat shrink on it. Ran it through that small
that's
hole.
Very neat, yeah.
And then this is it here.
Comes out to a male spade, okay. And that goes into the female for the power. Okay. We'll proof of the pudding is in the eating, as the saying goes. Oh yes. We're back to you again. And at the moment, what Adam is doing is he's tightening up one of the bolts on the headlight mounting bracket. We put some fresh earths on that, and they're powering the relays, some of the relays and some other connections here. So we put a new relay on here for the horn, and Adam's going to prove the horn works now. Yep,
cool.
That definitely works.
Very loud.
That's really good. We've also put in a new solid state relay rather than the little tin can that was there. So we're going to tidy up these connections with some heat shrink. Later on we just have it roughly mocked up like this for proof of concept, just to make sure that it's actually working before we get into doing the final tidy up. Going to make up a thing called an OR gate. It's a logic circuit made of little electronic components called diodes. And I did something like this for the indicator idiot light on the motorcycle last week. I didn't document it, and I kind of felt bad about that. So we need to make another little circuit for the motorcycle for the light. The idiot light for the, or not the idiot light, the light for the clocks, the speedometer and the tachometer, so at night time the light stays on. At the moment it's powered from the low beam light, because that was logically what we thought would work quite nicely, because you're driving on low beam most of the time. But Adam found that when we switch on to high beam, we lose the light on the clocks. So what we need for it are diodes. And what's going to happen is we're going to have a feed from, say, the low beam on that one and a feed from the high beam on that one. And now, a diode is kind of like a one-way valve, and it's a little electronic thing. It's quite a neat little invention. So this side, the black side without the stripe on it, is the anode or the positive side. And the side with the little stripe on it here, I don't know if you can see that there, that's the cathode or the negative side. So what we need to do is we need to twist these two together, these two output wires together. So this will be the input from the high beam and the low beam, and this will be the output to the clock lights, or the speedometer lights, or whatever you want to call them. So it's really simple. We just twist these together, like so. And these are going to feed the positive feed for each of the two clocks. We just solder this together, and then we're going to solder this onto the two wires that are going to the clocks. It's as simple as that. Just tidy that up. Now, we're going to leave this like this just for the solder just to dry. And what we're going to do is we're going to finish off this week's video. And we're going to leave you on a cliff edge wondering what the hell are we going to do with those two diodes and how we're going to connect them up. So if you're interested in that, come back next week.